Welcome. In this video, I'm going to demonstrate how to convert from a Cartesian equation to an equation in polar form. And before we go on, let's recall our tools when working with polar coordinates. We have x squared plus y squared equals r squared. X equals r cosine theta and y equals r sine theta. And that comes from the fact if we have a circle of radius r and some arbitrary point, say p equals x comma y, this resulting right triangle that forms with this angle theta, we can describe or we can demonstrate all of these hold based on this sketch here. I'm not going to go over that. Those of you in my Canvas course have seen that done on the online course. Otherwise, you can Google these relationships. But for now, just remember, these are our tools when working with polar coordinates. All right, so we have y equals 2x minus 1. Well, I know that y is equal to r sine theta. I also know that x is equal to r cosine theta. So I have r sine theta equals 2r cosine theta minus 1. Alternatively, I can write this as 2r cosine theta minus r sine theta equals 1. So this is r 2 cosine theta minus sine theta equals 1. And finally, I can see clearly that this is 1 over 2 cosine theta minus sine theta. And those of you in my course, remember there is a table earlier in your notes. As of version 5 of the notes, when this video was recorded, it's on page 177. So those of you in my course, look at page 177 of the guided notes template. R equals C divided by A times cosine theta plus B sine theta. A, B, C are non-zero constants. This gives you the equation of a line. So this is the polar equation of a line, which we have here. In our case, A equals 2, B equals -1, C equals 1. I hope you found this video helpful.